Trikke Co-rotation is a companion video to the article on qualitative body-powered trike physics at www.lastufka.net/trike with 2 Ks, of course. Riding a trike is all about co-rotation. The rider's body spins and turns the trike in such a way as to cause the trike and herself to rotate around alternating axes to each side. A trike traveling straight has no turn center. Steering to one side or the other creates a turn center that becomes a side axis. The trike always must be steered to one side or the other to transfer the rider's angular momentum. The 3 wheels constrain the trike and the rider to carve circular arcs, first to one side and then the other, the trike's characteristic snake-like path. This apparatus represents a trike, steered to roll around a circular path. A turn radius is not part of the trike, but acts like it is, because the wheels don't slip. The demo trike is free to rotate. Figure 1 diagrams this setup. A sideways force along any turn radius, out or in, does not add motion to the trike at all, because the wheels don't slip. In this configuration, the rider is the ballerina mentioned in the trike patents. The law of conservation of angular momentum mediates a matching or reflection of her spin's angular momentum back to herself and the trike around the turn axis, as she first spins up and then down. Ballerina and trike rotate together, that is, co-rotate, opposite to her body's spin. If she spins in the opposite direction against the turn, reflection causes her and the trike to go forward. A real rider spins himself and knows how to stop. Like the ballerina, his spin up and spin down is also a reflection process with the same results. A holding block now keeps the trike from rotating backward while the rider spins up to maximum. As he stops spinning, the law of conservation of angular momentum dictates that all of his angular momentum is transferred in the same direction around the turn axis, because the wheels don't slip. The trike's drive cycle begins with the trike steered in one direction and the rider at rest. Optimally, the rider spins up to the opposite side before steering past straight to reflect angular momentum into rotation around the turn axis. As steering straightens, the rider maximizes angular momentum in his body axis spin and the trike rotation slows to a stop. When steering straight ahead, the rider has maximum angular momentum, but the trike no longer rotates. The trike has no turn center, no turn axis, no turn radius, and no angular momentum, because the wheels are parallel and don't slip. At maximum body spin, the rider steers straight. The trike now responds like the one in the holding block demo, as the turn axis flips to the other side. Steering past straight, the rider's maximum angular momentum transfers into rotation around the turn axis as he stops spinning. Once the rider's spin momentum has transferred, he's set up perfectly to begin the next half of the drive cycle. Phase 1 and Phase 2 now repeat with the turn axis on the other side. Phase 1 reflects angular momentum from the rider while Phase 2 transfers it. In Phase 1 of a half drive cycle, the rider starts spinning before the guide wheel is straight. The trike gets a forward kick while steering to straight from angular momentum reflected during the rider's spin up. Then in Phase 2, as the guide wheel steers past straight, the turn axis flips to the other side. This aligns the spin and steering so that the trike gets a second kick as the rider's spin down transfers angular momentum. During each half drive cycle, the rider's body axis angular momentum is conserved, first by reflection around one parallel axis, then by complete transfer around a second parallel axis on the other side.